All right, take, I don't know, five, three. We'll get it one shot. Okay, so we're going to talk about the exciting world of energy, and you know my love of deriving equations. So we are going to talk about where do these energy equations come from? All right, so we did a lab where we found the force of a spring as it was compared to its displacement. And we found it was a beautiful line like this. Okay, now remember, energy is equal to the work done. And work is the area under a force distance graph. So that means, let's get some other colors going on here. Boop. That means that this right here, that area represents our displacement. My bad, that area represents our energy. I've done a few too many videos today. So, if we are going to go through this, we then have to just break it down. So we have this shape here. So we have the force of a spring times the displacement, but this is a triangle, so it's 1/2 base times height. And we have defined earlier that the force of a spring is equal to K delta X. So the spring constant times how far you pulled it. So when we smash that together, we get 1/2 K delta X squared, and that is equal to your elastic energy. All right, so that's one equation. Yay! For other equations, we're going to go back to our definition of work. Work is defined as the area under a force distance graph. So if I do this on other graphs, like let's say, I don't know, gravity, all right? So force of gravity, distance, force of gravity stays the same no matter what. We're not going to do like the depths of space stuff here. So for that, if you want to figure out how much gravitational potential energy is, it would just be Fg times that distance. All right, but Fg is actually mg. We know that from our past. And distance, since the vertical distance, we call it a height. So therefore, Eg equals mgh. Yay! Very exciting. All right, there's one left to go. Okay, and for this one, we're going to do red because it's very exciting. Now, this one is much more heavily based in mathematics. All right, so I'm going to grab our force times distance here. So we know that energy is equal to the work done. So that's the change in, oh my gosh, work is change in energy. How am I doing this? There we go. It's been a long day. Sorry, guys. So that's equal to force times your distance. So how far you go. So if we look at this, we've got force times that. Well, force could be replaced with, let me get my eraser out here because we're going to replace force with ma, because F equals ma. We know that. And distance, well, usually we talk about displacements, so we get ma delta x. Well, this is where it's interesting because we have another equation that has this delta x in it. So if we go back to some kinematics equations, we had this one here. V final squared equals V initial squared plus 2a delta x. And if I rearrange this, so you'll notice the delta x, a delta x is in both of them. So if I rearrange this, a delta x is equal to, we divide both sides by 2, 1/2 times the quantity final velocity squared minus your initial velocity squared, which is really your change in velocity squared. So now I can take that and do some substitution. And so I now have energy, specifically kinetic energy. I should say change in kinetic energy is equal to mass times this. Okay, so mass times that. So that is 1/2 m times your final velocity squared minus your initial velocity squared. And if I just kind of do some more algebra, we all love algebra. Everyone loves algebra. Distribute that 1/2 mv in here so we can kind of see it. We have our final, we have 1/2 mv squared minus 1/2 mv initial squared. So if you think about it, this is really your change in 1/2 mv squared, right? So therefore, this is our change in kinetic energy. So therefore, EK by itself is just 1/2 mv squared. And that's where we get our three different equations that we plan on using for energy. All right, so we have elastic is 1/2 kx squared. Gravitational is just mgh, the simplest one. And kinetic is 1/2 mv squared. So at the end of the day, that's kind of all you have to take away. And we'll be using those in class a whole lot. So hopefully that made sense. As always, if you have questions, you know where to find me.